So today we're going to be talking about simplifying a certain type of expressions. We've already talked about a little bit about simplifying expressions in the past, but today we're going to be looking at a little bit more of an advanced form of simplifying expressions. That's going to use a method called the FOIL method. Um, Now, this is not the only way of doing it, but it's a very popular way of doing it recently. But first, let's go back and review what a simplifying expression means. Let's look at some problems we should already know how to do. So the first one here, again, simplifying means we want to reduce the amount of stuff going on the problem. We want to reduce the problem down to as little as possible in terms of the amount of stuff going on. Usually that involves reducing the number of terms. So for example, in this case, we have 1, 2, 3, 4 terms. If I were to simplify this, usually that will go down from 4 to either 3, 2, or 1. And in this case, what we can do is simplifying involves combining like terms. So we have a 2x, we have a 5x, we put those together, and we get a 7x. We have a positive 3, we have a negative 7. We put those together, positive 3 and negative 7 would make negative 4. And that would be our simplified expression. So we went from having 4 terms to having 2 terms. Again, if you don't remember, terms are the stuff in between the plus and minus signs. So I have 4 things between the plus and minus signs here. So 2x, 3, 5x, 7. Here I only have 2. So this is simplified because there's less going on. It's still the exact same expression. So for example, if I plugged in 2 for x up here, so if I switched out all my x's for 2s, let me do this in a different color here just to make sure it's not too cluttered. If I do 2 times 2 plus 3, I'm going to try to squeeze this in here, plus 5 times 2 minus 7. Well, 2 times 2, that's 4, plus 3. 5 times 2, that's 10, minus 7. 4 plus 3 is 7, plus 10, minus 7. 7 plus 10 minus 7 is just going to be a nice even 10. So if I plug in 2 for x up here, I get 10. If I plug in 2 for x down here in the one I solved for, or the one I simplified, 7 times 2 is 14. 14 minus 4 is also 10. So the expression's value hasn't changed. Everything I plug in for x up here will give me the same result as if I plugged it in down here. So 5, 10, 20, whatever you want to plug in for x up here will get you the same answer as if you plugged in for x down here. It's just that the simplified one is a lot easier to work with because there's less going on. So simplification doesn't change the value, it just changes the look. It changes how much stuff is going on to hopefully make it easier to calculate. Now, there was another case here where we had something like this, where we had an outside number being multiplied to 2 inside numbers. So in this case, what we did is we took this outside number and we distributed it to both the inside terms. And what that meant is basically we took the outside number and multiplied it to everything on the inside. So 3 times x is 3x. 3 times 4 is 12. And that would be my simplified expression. Again, everything I plug in for x up here will work as if I plugged it in down here. And you can multiply terms even if they're unlike. So the 3 and the x, they're unlike terms, but I can multiply them together and make a 3x. That's okay. I could not add them together. So like example over here, I cannot take 5x minus 7 and get negative 2x. That does not work because they are unlike terms. But multiplication doesn't care. Multiplication says, just go ahead and slap them together, which is what we did. We took the 3 and the x and we slapped them together. So those are the two methods of simplifying we've already done. We've done the combining like terms, and we've done the distribution of a term. But now we're going to look at something a little different. For example, something like this. Quick little vocab here. These sections right here, this and this, they are called binomials. So this is a binomial. I'm going to try my best to do that. And I probably misspelled that, so I have to forgive me. But binomial, N-O-M-I-A-L. And again, that's probably misspelled, but I don't want to focus on that right now. So the reason we call these two sections binomials is because they have two terms. So x plus 3, we'll have one term, two terms, so it's called a binomial. X plus 4, one term, two terms, so it's called a binomial. Back here, this x plus 4, that would also be a binomial. One term, two terms, that's a binomial. This right here, the simplified form, is still a binomial. 3x plus 12, one term, two terms, so it's a binomial. This is a binomial. One term, two terms, so it's a binomial. Even if there's subtraction, it's still a binomial. This entire chunk right here would not be because it has more than two terms. But anything with two terms, we call it a binomial. The reason we do that is just so that people know how many terms are in there just by the name. So if I say I'm going to work with a binomial, you know I'm going to work with something with two terms, usually an x and some number else. Or it could be a y and an a as well. It doesn't matter as long as it has two terms. So let me give myself a little bit more workspace here. All right. So what if we want to solve or simplify something like this? Not solve, but simplify something like this. Well, we look at this here. It looks very similar to the one we did previously, right? It looks very similar to this, except that it's not just a 3. It's a whole nother binomial. It has more than just a number. So you might think, well, let's just do this. Let's just do x times x and 3 times 4. And that would give me x squared plus 12, right? So let's see if that works. Because again, if this works, that means any x I plug in up here, any number I plug in for x over here should give me the same result as if I plugged it in over here. So let's try 2 again. So if I replace all my x's with 2 here, so that'd be 2 plus 3. Let me make that 3 a little bit better. 2 plus 3 times 2 plus 4. Well, 2 plus 3, that's 5. 2 plus 4, that's 6. So that would get me 30. All right. So if I plug in a 2, I should get 30. So let's see if I get 30 over here. If I plug in a 2, I have 2 squared plus 12. 2 squared is 4 plus 12, which is 16. Well, that's definitely not 30. It's about half of 30 almost. So this actually does not work. This method of just multiply the x's and multiply the numbers, that does not work in here because I do not get the same answer as if I had it originally. Because simplifying should just change the look, not change the end result, the end value. So how do we do this then? How do we get it so that we can manipulate this so we don't have two binomials, but we still get the same answer as if we did? Well, the first and most popular process is a process called FOIL. This is an acronym here. It's not actually the FOIL you use. It's an acronym. And what does the acronym stand for? Well, it stands for this. First, outside, inside, last. And what this is simply an order. This is telling you how to multiply the terms together so that at the end you end up with something that is equivalent but looks different. That's hopefully more simplified. So what do you mean some order? Well, let me show you an example rather than just talking about it. Let's take this example here. F stands for first. So what this means is you're going to multiply the first terms together. Let me do this in a different color here. So this says multiply the first terms in each binomial together. So let's look at this binomial. What's the first term? Well, the first term is the x. So I'm going to multiply x times, what's the first term in this binomial? Well, the first term's x. So multiply x by x. And that will get me x squared. All right, all good there. Then the O says multiply the outside terms. So this says look at the entire expression. What are the outside-most numbers in this entire expression? Well, x here is kind of on the outside. It is the outermost number. It's the leftmost number. And 4 is the rightmost number. So it's kind of on the outside as well. So this says multiply x times 4 and get 4x. So the outside you can think of as the leftmost number, or value, I should say. It doesn't have to be a number, it could be a variable. But leftmost value and the rightmost value. So outside means multiply the leftmost term and the rightmost term. The inside, as you can probably guess, is the opposite. So the inside is the innermost numbers. So in this case, I have 3 and x. Those are the inside numbers compared to x and 4. So these numbers right here, those are my, those are my inside numbers. So I'd have 3 times x is 3x. And the last is going back to the individual ones. The last is the last term in each binomial. So 3 is the last term in the first binomial. 4 is the last term in the second binomial. So I would have 3 times 4, which would give me 12. Now, I'm not done quite yet, because what I have to do is I have to put all this mess together. So the way I would write this is I would write them by adding them all together, because these are all positive numbers. Positive x squared, positive 4x, positive 3x, positive 12. So I'd say x squared plus 4x plus 3x plus 12. But this isn't really simplified yet because I have 4 terms here. 1, 2, 3, 4. I started with 4 terms, and now I have 1, 2, 3, 4 terms. Well, that doesn't really help much. But if you notice here, hey, I have a 4x and a 3x together. So I can combine these two. I can add these together. These are like terms. 4x plus 3x is 7x. Plus x squared plus 12. And this is what usually will happen, is that when you multiply these things together, usually you will end up with 2 answers, 2 values that can then be added together as well. I cannot add the x squared to there because x squared and x are not like terms. And I can't add the 12 there because 12 and 7x are unlike terms. But I can add the 4x and the 3x together to make a nice even 7x. And then this would be my fully simplified answer right here. This is the fully simplified form. And again, if you want to check, plug in a value and see if it's consistent. So here, if I plugged in a 2 for x, on the other side, we saw that we got 30. Okay, so if I plug a 2 in for x here, I should get 30 in order to keep things consistent, right? So 2 squared. Well, that doesn't look like a square at all. Let me change that. So 2 squared plus 7 times 2 plus 12. So 2 squared, that's 4. 7 times 2, that's 14. And then 12 is just 12, of course. So we add all this mess together and we get a nice 30, which is what we had before when I plugged it in for this up here. So it remains consistent, only the look has changed. So this is a correct simplification. This right here is our correct answer. So FOIL, F-O-I-L, is a procedure that tells you the order in which to multiply the stuff in your 2 binomials. So it's basically telling you how, because again, you can't just multiply x to x and 3 to 4. You have to kind of switch it up a little bit. Now, personally, this is a good way to start out, but it's a little bit needlessly complicated because there's another way of thinking about it that does the same thing, but I think jives a little bit better. Now, some people disagree, so if you like the FOIL method and you like having this acronym to help guide you, go ahead and use it. But there's another way that's, again, if you have to put a name to it, it's basically called double distribution, although it really doesn't have a name. But that's the way you could label the process if you want to. But basically, all we did with FOIL, and all we can just really do, is take everything in the first binomial and multiply to everything in the second binomial. That's essentially what we did in FOIL. I'm going to take x times x and x times 4. Well, x times x, that's x squared. X times 4, that's 4x. Now it's the 3 term. 3 times x and 3 times 4. 3 times x is 3x. 3 times 4 is 12. Combine your stuff together and you get x squared plus 7x plus 12, just like we did before, because it wouldn't be a correct method if we got a wholly different answer, wouldn't it? So all I really do when I think about this, and once you get used to it, all you really have to do to think about it is you say take everything in the first binomial and multiply it to everything in the second binomial and do it term by term. So take the x and multiply it to everything in the second. Take the 3 and multiply it to everything in the second. Write down all your answers and then add them together by combining like terms if there are any. So if you want to think about FOIL, you can, but all FOIL is kind of a good introduction about what we're doing. And then once you get the idea that, well, all you're doing is multiplying everything in the first binomial to everything in the second binomial, then that's all you really have to do. You don't have to necessarily follow the order. Because a lot of people are afraid that if they don't follow the order of FOIL, that you get your answer wrong. And that's not true. Remember, FOIL is first, outside, inside, last. You actually do not have to do it in this order. You could do it like this. You could do outside, inside, last, and first. You could do it like that, and you'd still get the same answer. The reason that we use FOIL is because, well, it's an everyday item everybody knows about, so it's a good acronym to have. OILF doesn't really have a good acronym sounding to it. So if you do use FOIL, that's okay. Just don't get hung up on the order. Don't get hung up on the fact that if you accidentally do inside then outside, that you're all of a sudden going to have a wrong answer. You're not. As long as you do every step, it doesn't really matter the order, which is why I prefer this method, because it doesn't really have to have me do a certain order of things. It's just multiply everything in the first term to everything in the second term. Same answer either way. So let's try a few more examples here real quick. This one here, again, doing the same process. So x times x, so that's x squared. X times negative 2, remember it's a negative 2 this time, so it'd be negative 2x, or minus 2x. Now it's the 3's turn, so let me adjust my color here so we don't get too scrambled. 3 times x, that's negative 3x, so this is a negative 3 times x. And negative 3 times negative 2, remember your negatives. Negative 3 times negative 2 is positive 6. And then we start the last object of combining our like terms. Well, there is no x squared, so that stays. There is no other constant, so plus 6 will stay. But my two middle terms, negative 2x and negative 3x, those will multiply together and give me negative 5x. So this would be my simplified answer. X squared minus 5x plus 6. Again, start with 4 terms, end with 3. That's what we call simplifying. Now, the next one I'm going to do a little bit out of order. Okay, just to show you that it works even if you go out of order. So here we have 2x plus 3y. Here we have 5y minus 4x. It looks a little complicated, and it might seem that way at first, but it's no different than the first one we did. So let me do this. Let me multiply everything in the second term to everything in the first term. And let me do a little crazy here. Let me go a little crazy here. So let me do this. Negative 4x times 3y, that's negative 12xy. Remember, if you multiply values with two different variables, you just kind of slap them on at the end. So 3y, negative 4x, negative 12xy. Usually you write the variables in alphabetical order, but it doesn't matter as long as you write them all. Negative 4x times 2x. Okay, now be careful here. Negative 4 times 2, well, that's a negative 8. And x times x, that'd be x squared. So that'd be negative 8x squared. The negative 4 and the 2 make negative 8. The x and the x make x squared. Then we have our friendly guy, the 5. So 5y times 3y. 5 times 3, that's 15. Y times y, that's y squared. Then we have 5y times 2x. That's going to be plus 10xy. And then we start the nice process of pulling things together. So there is no x squared. Okay, there's no other x squared except for this. So I'll have negative 8x squared. There is no other y squared except for this. So I'd have 15 y squared. However, there are two xy terms. I have negative 12xy and positive 10xy. Because they both have the same variables, they both have xy and only one of each, then I can simplify them together. So negative 12xy plus positive 10xy is negative 2xy. As a little plus here because this 15y squared is a positive. So negative 12 plus 10 is negative 2, then xy and xy. Since I'm adding them together, just keep it as xy. And this would be my fully simplified mess here. Doesn't look like it's simplified because there's a lot going on in terms of variables, but it is still 3 terms compared to the 4 terms we started with, so we're good. And again, if you've noticed a pattern here, usually when you're doing stuff like this, when you're simplifying 2 binomials, you'll end up with something squared plus or minus something with a variable plus or minus some constant. Or if you have something like this, it'd be something squared plus or minus something with 2 variables plus or minus something else squared. So you will have a square every now and then in most cases, along with all the other junk as well. So this format right here, especially this one, this format right here, you'll get used to as you practice more of these. Now, the reason I like double distribution better than FOIL is because there is a second level to this as well. So let's look at this one here. We've been working with 2 binomials together, but this process of double distribution, this idea of taking everything in the first set and multiplying it to everything in the second set, that can be applied to however many terms you have, or however many, I shouldn't say terms, however many factors you have. So here I have 2, x plus 4, x plus 5, x minus 3. So I have essentially 4 factors, 4 things being multiplied together. Remember, a factor is something that's multiplied to something. So 2 is being multiplied to these, so 2 is a factor. X plus 4 is being multiplied to these, so x plus 4 is a factor. Right? The entire thing here, I'm talking about the entire chunk is a factor. So I have 4 factors here rather than just 2. So how would I do this? Well, I would do it the exact same way. What do you mean? Well, let's see. Let me start at the end here. I'm going to work from right to left. So I'm going to work with these 2 first, just these 2. So x times x, that's x squared. X times negative 3, that's negative 3x. Positive 5 times x, that is positive 5x. And positive 5 times negative 3, that's negative 15. Simplify my like terms, so x squared plus 2x, again, positive 5x, negative 3x, make positive 2x, minus 15. Put that in parentheses still, because it is still being multiplied to x plus 4 and 2. Now, what do I do here? Well, I continue the exact same process, except that now I'm going to be working with x plus 4 and this chunk over here, this what we call a trinomial. And I'll give you one guess as to why they call it a trinomial. Well, it's because it has 3 terms. Binomial, 2 terms. Trinomial, 3 terms. So how do I multiply a binomial to a trinomial? Well, I take everything in the first and multiply it to everything in the second. So x times x squared, x times plus 2x, x times negative 15. X times x squared, that's x cubed. X times 2x, that's 2x squared. X times negative 15, that's negative 15x. And then now is my 4's turn. So 4 times x squared, 4 times 2x, 4 times negative 15. Again, multiply everything in the first to everything in the second. So let me make that x there a little bit better. So 4 times x squared, that's positive 4x squared. 4 times positive 2x is 8x. 4 times negative 15, that's negative 60. Then as before, I look to see if there are any like terms I can combine. So there is no x cubed here that I see, so x cubed is just x cubed. X squared, I see a 2x squared and a 4x squared. So those together would make 6x squared. I see a negative 15x and a positive 8x. So negative 15x and positive 8x, that would get me negative 7x. And then there is no other constant, so I just write down negative 60 because that can't combine with anything. This is still in parentheses. And then I bring down my 2. And then lastly, I have to get rid of this 2 here. So once again, I take everything in the first, which is just a 2, and multiply it to everything in the second. So 2 times x cubed, that's 2x cubed. 2 times 6x squared, that's 12x squared. 2 times negative 7, that's negative 14x. 2 times negative 60, that's negative 120. And there is my fully simplified answer. 2x cubed plus 12x squared minus 14x minus 120. So I went from this up here, a lot of different factors, all the way down to something that's a little bit more simplified. But the process was the same each and every step. Take everything in the first and multiply it to everything in the second. Take everything in the first, multiply it to everything in the second. Take everything in the first, multiply it to everything in the second. That's what we did each and every time. And that's why I like using that method rather than just calling it FOIL, because FOIL doesn't work if you have something that's not a binomial. So FOIL doesn't work for this piece right here. FOIL cannot get you here because this has too many terms. But if you recognize the reasoning behind FOIL, if you recognize that FOIL is just another way of taking everything in the first and multiplying to everything in the second, then it becomes a little bit easier to apply to unknown aspects. Again, that's the difference between knowing and understanding math. Knowing math would be knowing how to FOIL, and that's good. That's a good start. Understanding it would be knowing, okay, what's the reason that why FOIL works, and what's the main idea behind FOIL, and how can I alter that to apply to situations that are a little bit different. And that's when you understand math, if you know how to do that process there. So, simplifying expressions using the FOIL method, or if you want to call it double distribution, you can do that too. But using those two methods, that's how I multiply things when there is a binomial times a binomial. This is a little bit more advanced. Normally in class, we will focus on something like this. So x plus 2 times x minus 4. So this is a typical problem we'll focus on in class, a binomial times a binomial. But again, knowing how to do this is a good little push if you're looking for a way to kind of improve your understanding a little bit. Okay. So, hope you enjoyed the video. Have a good day.